Okay guys, we're going to go over how to do a couple of the different problems that were on the assessment for Unit 1. So the first thing we're going to go over is how to convert temperatures. So if we're in Fahrenheit and we need to convert over to Celsius, the formula is going to be C equals F minus 32 divided by 1.8. So wherever the F is, you're going to put in that degrees. So it's going to be 104 minus 32 divided by 1.8. So, 104 minus 32 is 72 divided by 1.8. And that's going to give you 40 degrees. And remember, it's going to be in Celsius, so 40 degrees Celsius. Now, if we were going the opposite way and going from Celsius into Fahrenheit, the formula for that one is F equals 1.8 times C plus 32. So wherever your C is, you're going to put that number in. So we've got 1.8 times 104. You're going to do that first and then add 32. So 1.8 times 104 is going to give us 187.2, and then add 32. Plus 32 gives us 219.2 degrees Fahrenheit. Okay, let's go on to the next one. The next one is talking about flow rates. So they're telling you right here, drops per minute. There's a couple different ways to do this. I'm going to show you the way that I do it. I put over here what I'm looking for. So I'm looking to have drops starting, and it's going to be up on the top, and by the end we're going to have minutes on the bottom. So this is called dimensional analysis. So I look in here for what says drops. Right here it's telling me 15 drops of fluid, go with 1 milliliter. So I write 15 drops, because what I'm looking for is always going to go on the top, and then that 1 milliliter. Then I need something to go with milliliters up here. Now the only other thing I have here that would be even close to milliliters is a liter. So if we remember in our conversion chart that 1,000 milliliters equals 1 liter, on hand we have 1 liter, and it tells us here that it's going to be given over 7 hours. So put in here 7 hours. Now, the only thing we don't have up in the problem listed is minutes, but we all know that 60 minutes is 1 hour. So I can put in here 1 hour, 60 minutes. Now, if we get rid of the units that match on top and bottom, we're left with drops on top, minutes on bottom, and that's exactly what I'm looking for right here. I have drops on top, minute on bottom. The next step we need to do is multiply everything across the top. So I have 15 times 1,000 is 15,000, times 1 is 15,000, times 1 is 15,000. So we have 15,000 on the top. And then we have 1 times 1 is 1, times 7 is 7, times 6 is 420. When you get to this point right here, the only thing you need to do is divide. So we're going to do 15,000 divided by 420. So you're going to put that in your calculator. So we have 15,000 divided by 420 is going to give us 35.7. Now, because we're talking about drops, you can't actually divide a drop into any kind of decimal. So because it's above 5, we're going to go ahead and round up and say it's 36 drops per minute. Okay, let's go on to the next one. The next one's asking us for a reconstituted vial of penicillin G potassium contains 250,000 units per ml. We need a dose of 80,000 units, and they want to know how many mLs that's going to be. So we're looking for mLs, so they're going to go on top. So here I have something that has 1 ml, 250,000 units. And then here I have 80,000, which is what I'm looking for. Get rid of your units because they're on top and bottom, so we're crossing that out. Multiply across the top. 1 times 80,000 is 80,000. And bring over your 250,000. So we just have 80,000 divided by 250,000. So we'll do that in our calculator. And it gives us 0.32 mLs. That we would typically just round to 0.3 mLs because it's too hard to measure to our hundredths with a syringe. The next one we have is how long will it take for an antibiotic infusion of 150 mLs to complete at a rate of 20 drops per minute in infusion tubing that's calibrated at 60 drops per ml. So the first thing I'm going to ask myself is, what are they looking for? They're looking for how long, which means they're looking for a time period. So the next thing I look is what in here has time. This little conversion right here is the only thing that has time. So that means I'm going to put my minutes on top because I'm looking for something that has time. So 1 minute has 20 drops. Our tubing is 60 drops for 1 ml, and we have a total of 150 mLs. So if we cross out all of our units, we're left with just minutes, which is what we're looking for. So we have 1 times 60 is 60. 60 times 150, put that in the calculator, it's going to be 9,000. And then 20 times 1 is just 20. So if we divide that out, 9,000 divided by 20, that's going to give us 450 minutes. Now, they might be asking for hours, so it just depends. If they are asking for hours, you're just going to divide 450 by 60, and every hour has 60 minutes. So 450 divided by 60 is going to be 7.5 hours. I hope that clears up any confusion on any of the math. Let me know if you have any additional questions about this, and I can do some other ones if you have specific math questions. All right, thank you very much. Bye.